Good morning, my dear students. In the previous video, we have discussed certain results from trigonometry, application of which in one of the problems will be done at the beginning of this particular video presentation. Then we'll do one more problem. The problem goes like this. See here, in triangle ABC, prove that a cube into cos b minus c plus b cube into cos c minus a plus c cube into cos a minus b to b is equal to 3abc. That's what you're supposed to prove anyway. If anybody wants to follow this particular answer, better you go through the proofs which were done in the previous video. It will be easier for you to follow. Just listen carefully. Answer, the proof goes like this. Let me start with LHS. A cube into cos b minus c plus b cube into cos c minus a plus c cube into cos a minus b. What I will do is, I will write a square into a cos b minus c plus b square into b cos c minus a plus c square into c cos a minus b. I need it, therefore I do. I have seen just now in the previous video one of the results. A cos b minus c can be written as b cos b plus c cos c. Check for the result, it is already done. Similarly here it will be c cos c plus a cos a. Similarly here it will be a cos a plus b cos b. You can check the result. Therefore here I mean to say a square b cos b, and I will group a b square cos a. Similarly I will group. Similarly I will group b square c cos c plus bc square cos b. I will group. Then let me rub this part a little bit. Rub this line on a little bit. Okay, I'm going to write here, and here I'll group a square c cos c plus I will again group ac square cos a. Now what I will do is I'll take AB as common. After taking AB as common, I will get a cos b plus I'll get b cos a. Similarly, from this I'll get BC as common. I'll get b cos c plus c cos b. Similarly here I'll take CA as common. Taking CA as common, I'll get a cos c plus c cos what is this exactly? AC square, this is cos a. Therefore c cos a. Therefore this is nothing but c is equal to a cos b plus b cos a. Similarly this is nothing but a is b cos c plus c cos b. The proof of which we have already seen. This is nothing but b is a cos c plus c cos a. Therefore this is simply reduced to 3abc. This is my right hand side. I explain once again. Let me explain the whole lot again. I start with LHS. A cube into cos b minus c plus b cube into cos a minus a plus c cube into cos a minus b can be written as a square into a cos b minus c plus b square into b cos c minus a plus c square into c cos a minus b. Can be written as a square into these three results we have proved in the previous video. Check the video if you want. This is equal to b cos b plus c cos c. This is equal to c cos c plus a cos a. This is equal to a cos a plus b cos b. Now multiply this a square, b square, c square inside, but group a square b, ab square quantities, and b square c, bc square quantities, a square c, ac square quantities. A square b cos b plus ab square cos a plus b square c cos c plus bc square cos b plus ac square cos a, a square c, where is it? A square c cos c plus ac square cos a. Now taking AB as common, I'll get a cos b plus b cos a. Taking BC as common, I'll get b cos c plus c cos b. And taking CA or ACA, either way you can write. CA is common, I will get A cos C plus C cos A. But A cos B plus B cos A is nothing but C. C is A cos B plus B cos A. The proof we have seen just now in the previous video. Just check. A is nothing but B cos C plus C cos B is replaced by A. Then B is nothing but A cos B plus C cos A is nothing but B. C is A cos B plus B cos A. A is nothing but B cos C plus C cos B. B is nothing but C cos A plus A cos C. It's interchange anyway, it doesn't matter. ABC plus ABC plus ABC gets reduced to 3ABC. That's the result you are supposed to prove anyway. That's what I am supposed to prove. It's not at all a difficult task, but you need to recall the proofs we have already done in the previous video. If anybody wants to recall the proofs, go through the previous video, then you'll be able to definitely follow what it is exactly for this application, for the application of this particular problem. Go through the previous video. I'm just taking those things for granted. I wanted to do this in the previous video itself, but I want to minimize the time, therefore I couldn't accommodate in the previous video. Okay, next, in triangle ABC, prove that there is another result to be proved. Sine 2A plus sine 2B plus sine 2C is 4 sine A, sine B, sine C. This is called triangular identity. Okay, within the triangle these results will be true. Let me just start with LHS. Sine 2A plus sine 2B plus sine 2C. I put this in brackets. Use the rule sine C plus sine D. 2 sine C plus D by 2 cos C minus D by 2. 2 sine 2A plus 2B by 2 cos 2A minus 2B by 2 plus, here I use it as 2 sine C cos C. Sine 2A formula I am using. Here this is nothing but 2 sine A plus B cos A minus B plus 2 sine C cos C. 2 sine, I will write this as pi minus C cos A minus B plus 2 sine C cos C. I just write as it is, 2 sine C cos C. This is 2 sine C cos C. One second. Yeah. 2 sine C cos C. Okay, just listen carefully. This is nothing but 2 sine C cos A minus B plus 2 sine C cos C. Let me just take 2 sine C as common. I have cos A minus B plus cos C. Now 2 sine C into cos A minus B plus cos pi minus A plus B I will be able to write. Since A plus B plus C is pi in any triangle. Okay, here I mean to say cos A minus B minus cos A plus B, because cos pi minus theta is minus cos theta, which is reduced to 2 sine C into 2 sine A sine B. This is another formula, cos A minus B minus cos A plus B, 2 sine A sine B, which is nothing but 4 sine A sine B sine C, which is my right hand side, practically speaking, which is my right hand side. Let me just explain the whole lot again. Let me start with LHS, sine 2A plus sine 2B plus sine 2C. I am grouping these two. I am using the formula of sine C plus sine D. Sine C plus sine D is 2 sine C plus D by 2 cos C minus D by 2. Instead of C I have 2A, instead of B I have 2B. 2A plus 2B by 2 becomes A plus B. 2A minus 2B by 2 becomes A minus B. Sine 2C, I write it 2 sine C cos C. One of the formulae for sine 2A. Okay. Now this A plus B can be replaced by pi minus C. A plus B plus C is pi. Sine pi minus theta is sine theta. Take 2 sine C as common. Cos A minus B plus cos C. This cos is not very clear. I'll just rewrite if you want. Doesn't look like cos. Okay, I'll rewrite if you want. This is cos C. Okay. This C can be replaced by pi minus A plus B. But cos pi minus theta, the second quadrant, cosine is negative, minus cos A plus B. Cos A minus B minus cos A plus B is nothing but 2 sin A sin B. Already one 2 is there. Therefore, it gets reduced to 4 sin A sin B sin C. Therefore, rest we'll discuss in the next video. Thank you students for patient watching.